channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry class 11th, and that is your class is your third 21th. We had done 28 classes in the last sessions of chemistry, where we had completed your part 1. In that we had completed unit 7, and unit 8 is your redox reaction, which we had completed in part 2. Unit 9 is your hydrogen, and unit 10 is the S block element, where we had completed almost topics that we had covered up, and this will be, hopefully if it has not been exceeded, it will be the last class of S block element in the chemistry part 2 for class 11th. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So here we go for it. So today we'll discuss about the anomalous behavior of beryllium. In terms of anomalous behavior of beryllium here. In this, beryllium, the first member of the group 2 metal, that shows anomalous behavior as compared to the magnesium and rest of the members. Further, it shows diagonal relationship to aluminum, which is discussed subsequently. In that, the beryllium has exceptionally small atomic and ionic sizes, and thus does not compare well with other members of the group, and because of the high ionization enthalpy, the small size, it forms compounds which are largely covalent and get easily hydrolyzed. Beryllium does not exhibit coordination number more than 4, as it is a valence shell. There are only 4 orbital. The remaining members of the group that can be a coordination number of 6 by making use of a d orbital. The oxide and hydroxide of beryllium, unlike the hydroxides of other elements in the group, are amphoteric in nature. Now we're gonna discuss the another one, that is being the diagonal relationship between beryllium and aluminium. So here we go for it. So diagonal relationship between beryllium, that is for beryllium and aluminium. So diagonal relationship between beryllium and aluminium here. The ionic radius of Be2 plus is estimated to be 31 pm, and the charge radius ratio is nearly the same as that of Al3 plus ion, and hence beryllium resembles aluminium in some ways. Some of the similarities are, like aluminium, beryllium is not readily attacked by acid, and because of the presence of an oxide film on the surface of the metal, beryllium hydroxide dissolves in excess of alkali to give a beryllium ion, which is BeOH whole 4 2 minus, that is just as aluminium hydroxide gives aluminate ion. Another is that the chlorides of both beryllium and aluminium have Cl- bridge chloride structure in vapor phase. Both the chlorides are soluble in inorganic solvent and are strong Lewis acid, and they are used as Friedel's Kraft catalyst. Another is the beryllium and aluminum ion have a strong tendency to form the complexes, which is Bf4 2 minus and AlF6 3 minus here. I will discuss some important compounds of calcium here. So that is been as follows. In the same way, some important compounds of calcium we discussed here. Some important compounds of calcium. So here for that, important compounds of calcium are calcium oxide, calcium hydroxide, calcium sulfate, calcium carbonate and cement. These are industrially important compounds, and the large scale preparation of these compounds and their uses are described below. First we'll discuss about the calcium oxide or quicklime, which is CaO. Calcium oxide and a quicklime, that is CaO here. In the same way, it is prepared on the commercial scale by heating limestone, which is CaCO3, in a rotary Kelvin at 1070 to 1270 Kelvin. So we have that equation will be as follows. CaCO3 in the presence of heat, CaO plus CO2. On the same way, the carbon dioxide is removed as soon as it is produced to enable the reaction to proceed to completion, and the calcium oxide is a white amorphous solid. It has a melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moistures and carbon dioxide. So for that, it will be CO plus H2O will give CaOH twice. The another one, CaO plus carbon dioxide, which is CaCO3. In the same way, the additions of limited amount of water that breaks the lump of lime. This process is called slaking of time, where quick lime slaked with soda gives solid soda lime. Being a basic oxide, it combines with acidic oxide at high temperature, and that will give CO plus SiO2 will give CaSiO3, and 6 CaO plus P4O10 will give 2 Ca3PO4 twice. Now discuss about the uses here. So that has been the uses we'll discuss as well. So we have as follows. In terms of uses, it is an important primary material for manufacturing cement, and it is the cheapest form of alkali. It is used in the manufactures of sodium carbonate from caustic soda. It is employed in the purification of sugar and its manufactures of the dye stuff. Now discuss about the calcium hydroxide, which is a slaked lime or CaOH twice. So we'll go for it. It is a slaked lime, that is CaOH twice. So with the same we go for it, and here calcium hydroxide is preferred by adding a water to a quicklime, which is CaO. It is a white amorphous powder and it is a sparingly soluble in water. The aqueous solution is known as a lime water, and the suspensions of slaked lime in water is known as a milk of lime. When carbon dioxide is passed through the lime water, it turns milky due to the formation of calcium carbonate, and that will be formed CaOH twice plus CO2 will give CaCO3 plus H2O. So on passing excess of carbon dioxide, the precipitate dissolve to form the calcium hydrogen carbonate, which will be give you so here the milk of lime react with chlorine to form a hypochlorite and a constituent of bleaching powder, which will give plus CaOCl 2 plus 2H2O. This is CaCl, and that is CaOCl2 is your bleaching powder. Yeah, this is your bleaching powder here. On the same way, we'll talk about for the uses of this. In terms of uses here that we discussed as well, it is used in the preparations of mortar and a building material. It is used in a whitewash due to its disinfectant nature. It is used in the glass making, in tanning industry, for the preparations of bleaching powder, and for purification of sugar. Now discuss about another one, which has been the calcium carbonate, which is CaCO3. In the same way for the calcium carbonate CaCO3 here that we gonna discuss here. In the same way for calcium carbonate, the calcium carbonate occurs in nature in several forms, and the limestone, chalk or marble, etc. It can be prepared by passing carbon dioxide through slaked lime, or by the addition of sodium carbonate to calcium chloride. Where we have your equations for the same, it will be as follows. The first equation will be CaOH twice plus CO2 will give CaCO3 plus H2O. Another is CaCl2 plus Na2CO3 will give CaCO3 plus 2 NaCl. Yeah. So here for the excess of carbon dioxide, that should be avoided, since this leads to the formations of water soluble calcium and hydrogen carbonate. So calcium carbonate is a white fluffy powder. It is an amount almost insoluble in water, and when heated to 1200 Kelvin, it decomposes to evolve the carbon dioxide, and it will be forming CaCO3 and 1200 Kelvin, CO plus CO2. It is react with dilute acid to liberate the carbon dioxide. CaCO3 plus 2HCl will give CaCl2 plus H2 plus CO2. CaCO3 plus H2SO4, CaSO4 plus H2O plus CO2. Now we'll talk about for the uses of it. So we go for it. The uses of calcium carbonate. Uses of calcium carbonate, it is used as a building material in the form of a marble and to be manufactured of a quicklime. The calcium carbonate along with magnesium carbonate is used as a flux in the extractions of metals such as iron, especially precipitated CaCO3 is extensively used in the manufacture of high quality paper. It is also used as an antacid, mild abrasive in toothpaste, and a constituent of chewing gum and a filler in cosmetics. This is all that what we'll have. Now we discuss about the calcium sulfate, which is plaster of Paris, CaSO4 half H2O. So we go for it. Calcium sulfate, which is plaster of Paris, CaSO4 dot half H2O. In the same way, it is the hemihydrated of calcium sulfate is obtained when gypsum, which is CaSO4.2H2O, is heated at 393 Kelvin, and that is the reaction we have. 2 CaSO4.2H2O heated, so 2 CaSO4 twice H2O plus 3 H2O. So here above 393 Kelvin, no water of crystallization is left and an anhydrous calcium sulfate. CaSO4 is formed and this is known as a dead burned plaster here. Now we go for another one in the detail. It has a remarkable property of setting with water, and on mixing with an adequate quantity of water it forms a plastic mass, and that gets into a hard solid in 5 to 15 minutes. Now we go for the uses for plaster of Paris here. Although the uses we have here, that the largest use of plaster of Paris is in the building industry as well as plasters. It is used for embolishing the affected part of organ where there is a bone fracture or sprain, and it is also employed in dentistry, in ornamental work, and for making a cast of statues and bust. Coming towards the cement, in terms of cement here, cement is an important building material. It was first introduced in England in 1824 by Joseph Aspdin. It is also called as a Portland cement because it resembles with the natural limestone quarried by the Eccles of Portland, that is England. Cement is a product obtained by combining a material rich in lime, which is CaO, with other materials such as clay, which contains silica, SiO2, along with the oxides of aluminium, iron, and magnesium. The average compositions of Portland cement is CaO and like 50 to 60% SiO2 is your 20 to 25%. Al2O3 is 5 to 10%. MgO is 2 to 3%. Fe2O2 is 1 to 2%, and SO3 is your 1 to 2%. And for a good here in the same way that the percentage we are talking about. So for a good quality cement, the ratio of the silica SiO2 to alumina, that is Al2O2, should be between 2.5 and 4, and the ratio of the lime CO and total mass, the total of the oxide silica SiO2, alumina Al2O3, and iron Fe2O3 should be close as possible to 2 here. Now, other than that, we talk about the raw material for the manufacture of the cement, that are limestones and clay. When clay and limestones are strongly heated together and they fuses and then react to the form cement clinker. The clinker is a mixed with 2 to 3% by weight of gypsum and CaSO4 2H2O to form a cement. Thus, the important ingredient that is present in the Portland cement are the dicalcium silicate, which is Ca2SiO4, which is 26%. Tricalcium silicate, that is Ca3SiO5, is 51%, and tricalcium aluminate is Ca3Al2O6, 11%. Now we talk about for the setting of cement here. Setting of cement in terms of it, we'll discuss here. A setting of cement, when mixed with water, the setting of cement take place to give a hard mass. This is due to the hydrations of molecules to the constituents and their rearrangement. The purpose of adding gypsum is only to slow down the process of setting the cement so that it gets sufficiently hardened. We talk about for uses of this. The uses that the cement has become a commodity of a national necessity for a country, for any country, next of iron and steel. It is used in the concrete and reinforced concrete in plastering and the constructions of bridges, dams, and buildings. Now I'll discuss the last topic of this unit is your biological importance of magnesium and calcium. Here, an adult body that contained about 25 gram of magnesium and 1200 gram of calcium compared with only 5 gram of iron and 0.06 gram of copper. The daily requirement in the human body has been estimated to be 200 to 300 mg. All enzymes that utilize ATP in the phosphate transfer require magnesium as a cofactor. The main pigment for the absorption of light in plants is chlorophyll, which contains magnesium. About 99% of the body. Calcium is present in bones and teeth. It also plays an important role in the neuromuscular function, interneural transmission, cell membrane integrity, and blood coagulations. The calcium concentrations in plasma is regulated at about 100 mg liter inverse. It is maintained by the two hormones, and that is your calcitonin and parathyroid hormone. Do you know that the bone is not as an inert and unchanging substance but is continuously being stabilized and redeposits to the extent of 400 mg per day in a man, and all this calcium passes through the plasma here. Now you go for another one, that the S block of the periodic constituents, group 1 alkali metal and a group 2 or alkaline earth metal. They are so called because of their oxides and hydroxides are alkaline in nature. The alkali metal are characterized by one s electron and the alkaline earth metal by two s electron in the valence shells of their atom. These are highly reactive metal forming a monopositive M plus and dipositive M2 plus ions respectively. On the same way, here in the same way we talk about it. So yes, there is a regular trend in the physical and the chemical properties of an alkali metal with increased atomic numbers, and the atomic and the ionic sizes increases as the ionization enthalpy decreases here. So on the same way, the atomic and the ionic sizes increases and ionization enthalpy decreases systematically down the group. Somewhat similar trends are observed among the properties of the alkaline earth metal. The first element in each of these groups, lithium in group 1 and beryllium in group 2, shows similarities in properties to the second member of the next group, and such similarities are termed as diagonal relationship. In the periodic table, as such, these elements are anomalous as far as their group characteristics are concerned. The alkali metals are silvery white, soft, and low melting, and they are highly reactive. The compound of alkali metals are predominantly ionic, and their oxides and hydroxides are soluble in water, forming strong alkalis. Important compounds of sodium include sodium carbonate, sodium chloride, sodium hydroxide, and sodium hydrogen carbonate. Sodium hydroxide is manufactured by the Castner-Kellner process and sodium carbonate by a Solvay process. The chemistry of the alkaline earth metal is very much like that of the alkali metal. However, some difference arises because of the reduced atomic and ionic sizes and increased cationic charges in the case of the alkaline earth metal. The oxides and hydroxides are the basic, then the alkali metal oxides and hydroxide. Industrially important and compound of the calcium includes calcium oxide, which is lime, calcium hydroxide, which is slaked lime, and calcium sulfate, which is plaster of Paris, calcium carbonate, limestone, and cement. Portland cement is an important construction material. It is manufactured by heating in a pulverized mixtures of limestones and a clay in a rotatory kiln, and the clinker thus obtained is mixed with some gypsum 2 to 3% to give the fine powder of cement. All these substances find variety of uses in different areas. Monovalent sodium and potassium ion and a divalent magnesium and the calcium ion are found in large proportions of biological fluid. These ions perform important biological functions such as maintenance of ion balance and nerve impulse in conduction. In the same way, we talk about for the ending it up the questions here. So the questions we have: what are the common physical and chemical features of alkali metal? Discuss the general characteristics and gradations in properties of alkaline earth metal. Why are alkali metals not found in nature? Find out the oxidation state of the sodium in Na2 and O2. Next is your explain why is sodium less reactive than potassium. Next is compare the alkali metal and alkaline earth metal with respect to the ionization enthalpy, basicity of oxides, and solubility of hydroxides. Next is your in what ways lithium shows similarities to magnesium in its chemical behavior. Next is you explain why can alkali and alkaline earth metal not be obtained by the chemical reduction method. Next is your why are potassium and cesium rather than lithium used in the photoelectric cell. Next, why an alkali metal dissolve in liquid ammonia, the solution that can acquire different colors. Explain the reasons for this type of a color change. And next is your beryllium and magnesium do not give color to flame whereas other alkaline earth metal do so. Why? Next is discuss the weight gas reaction that occurs in the Solvay's process. Next is your potassium carbonate cannot be prepared by the Solvay process. Why? Next question is your why is Li2 CO3 decomposed at the lower temperatures whereas Na2CO3 at higher temperatures. The next question we have here that is being as follows is your compare the solubility here in the same way. that the compare the solubility and the thermal stability of the following compound of the alkali metal with those of the alkaline metals are nitrates, carbonates, and sulfates. You have to answer it out. Starting with the sodium chloride, how would you proceed to prepare sodium metal, sodium hydroxide, sodium peroxide, sodium carbonate? Next is what happens when magnesium is burned in air. Quicklime is heated with silica and chlorine react with slaked lime. Calcium nitrate is heated. Next is you describe the two important uses of each of the following, which is caustic soda, sodium carbonate, and quicklime. Next is you draw the structures of BeCl2, which is vapor, BeCl2 solid. The hydroxide and the carbonates of the sodium and potassiums are easily soluble in water, while the corresponding salts of magnesiums and calciums are sparingly soluble in water. Explain. Describe the importance of the following: limestone, cement, plaster of Paris. Next is your why are lithium salts commonly hydrated and those of the other alkali ions usually anhydrous. Why is LiF almost insoluble in water, whereas LiCl soluble not only in water but also in acetone? Next is explain the significance of sodium, potassium, magnesium, and calcium in a biological fluid. Next is what happens when sodium metal is dropped into water. Sodium metal is heated, its free supply of air, sodium peroxide dissolves in water. Another is the comment on each of the following observation. The mobilities of the alkali metal ions in aqueous solutions are Li plus, Na plus, K plus, and Rb plus, and Cs plus. Then lithium is the only alkali metal to form nitride directly. Then another state as to why solutions of Na2CO3 is alkaline. Alkali metal are prepared by electrolysis of their fused chloride. Sodium is found to be more useful than potassium. Another is write balance equation for reaction between Na2O2 and water, KO2 and water, Na2 and CO2. How would you explain the following observation? BeO is almost insoluble, but BeSO4 is soluble in water. BaO is soluble, but BaSO4 is insoluble in water. Li is lithium iodide is more soluble than potassium iodide in ethanol. That you have to answer right. Which of the alkali metal is having the least melting point? Options are sodium, potassium, rubidium, cesium. Which one of the following alkali metal give hydrated salt? Which is lithium, sodium, potassium, cesium. Another is which one of the alkali earth metal carbonates is thermally the most stable? That is the last. MgCO3, magnesium carbonate, calcium carbonate, and strontium carbonate, and barium carbonate. So you have to answer it out accordingly. Now we're gonna end up with this, and we'll continue the next class in the next session, and that is of course 22th class, which is the P block element, which will be continuing. So here we're gonna end up with. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share, and subscribe so that many and maximum people can get the information at once, and another you can also enjoy the video as well. Other than this, we had done your reasoning, which is verbal reasoning and non-verbal reasoning. Coming towards your physics, which we had started with the physics part 1, quantitative aptitude. We had started with arithmetical ability. We'll be showing and ending it up as well. In terms of chemistry part 1, so yes, you had done your unit 1, which is some basic concepts of chemistry. Unit 2 is your structures of an atom. Unit 3 is classifications of element and periodicity in properties. Unit 4 is chemical bonding and molecular structures. Unit 5 is traces of matter. Unit 6 is thermodynamics. Unit 7 is your equilibrium. And Unit 8, which we had covered up, is your redox reaction. Unit 9 is hydrogen. Unit 10 is the S block element, which we are in. After completing that, we had completed that and in this class, and unit 11 we'll start discussing about the P block element. Unit 12 is organic chemistry, some basic principles of technique. Unit 13 is hydrocarbons. Unit 14 is environmental chemistry. Then we're gonna end up with. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share, and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you.